Oh, hi. Welcome back for day 2 of post-COVID science online. Today we're looking at parts of the respiratory system and how it works. Again, I will fly through the slideshow. We've got a couple of videos and flash animations to look at as we go. You can pause at any time to help you fill in the blanks, and you can mute at any time if you get tired of listening to me. I'm going to try to go a little quicker this time, so you may need to have your finger on the pause. Respiratory system, largely responsible for bringing oxygen in and getting carbon dioxide out. There's a quick picture of it. Bronchus means branch. That's where the trachea branches into two parts, goes into the lungs. Rib cage protects it all, and the diaphragm is the part across the bottom. There is a quick summary of the parts you need to know. Mouth, nose, lung, trachea, alveoli, bronchi, diaphragm, and bronchioles. Starting with mouth and nose. This is where air enters the respiratory system. Not much more to it than that. Some tissue in the nose also helps to warm and moisten the air on the way in so that it's not harmful to the softer tissue lower down the airway. Trachea is this rigid pipe protected by a tough layer of cartilage. The voice box or larynx sits right up here. I'm going to show you a video in a minute of how the voice box works, how the larynx works. There are tissue stretched across this tough cartilage opening, very much like strings stretched across the body of the guitar. We change the shape and sound, the shape of the sound by changing the shape of our mouth, and you change the pitch by tightening or loosening these vocal cords the same way you tighten or loosen the strings on a guitar. I'll show you that on a video coming up in a second. If you feel your own trachea, you'll notice bands or ridges of cartilage on the outside to protect the trachea and the voice box. If we look at a cutaway, you've got the tough cartilage layer here, and oh, there's the esophagus, which we talked about yesterday in the digestive system. The esophagus is a muscle-lined flat tissue that actually stays closed most of the time unless you're swallowing. The trachea has to stay open, and that's why it's got the cartilage layer in front. Here's what it looks like when we actually look down a patient's throat and watch those vocal cords vibrate. It looks like this video right here. These are the vocal cords that vibrate, producing the sound. When she breathes in, you can see those cartilage ridges all the way down. So that's what it looks like when you shove a camera down your throat. If you want to see more of that video, you can just do a search for those words right there and it'll pop up with this video. I'm done with that. That's what the larynx looks like inside. This is where the magic happens. This is where the gas exchange takes place inside your lungs. Here's what those lungs look like. I'm really sorry that I couldn't bring you in to see this. This is what we were going to do.
This part here is the trachea. See all the bumps? Okay, all these bumps help protect the inside. You can feel just how bumpy it is just by running your fingers across the top.
Okay, well. No, don't touch me. You touched me.
Okay, and ready? Charity, go ahead, Charity.
Stop pushing.
Okay, and then of course there's this part here, which is actually the lung. Okay, you just give it a feel. It feels very almost
It's like
slimy.
Jello.
Oh,
Oh,
my God.
Okay. Now,
I was gonna put it too.
I am going to put it.
Oh, is that gonna come out?
There's an arrow here. That means inside down. Okay. Wait until
Oh, you gonna put your mouth on it?
Wait until it's fully inflated before you guys touch it, okay? Because I want to make sure it gets the right size. You ready for this? Okay. Ready? Watch.
Blow it again. Blow until it just blows up. That is cool. This is blow all over your face, Rachel.
That is so cool. It's like he's on a punching bag. That is so cool.
Okay.
So that's what it looks like when you actually see a lung expanding. Again, I'm really sorry I couldn't bring you in here for that. But video, next best thing. The bronchi. Bronchi means branch. It branches into left and right bronchi. The bronchi further branches into smaller branches called bronchioles. So bronchiole means small branches. Alveoli are the small air sacs. They're just one cell layer thick, and this is where the oxygen and carbon dioxide gas is exchanged. The alveoli is really the most important site and structure within the respiratory system. That's where blood and oxygen meet for the first time. This is what it looks like. The air coming in has more oxygen than the blood coming back to the alveoli. So the oxygen moves from higher concentration of oxygen to lower concentration of oxygen. That's a process called diffusion. Now the carbon dioxide moves in exactly the opposite direction. Since the carbon dioxide just came back from doing a lap around the body, concentration of carbon dioxide is higher in the bloodstream than in the air you just breathed in, so the carbon dioxide diffuses into the alveoli where you breathe it out. This is what it looks like. So the oxygen diffuses onto these red blood cells, the carbon dioxide diffuses off. You'll notice that they change color just a little bit as the carbon dioxide leaves the red blood cell and the oxygen jumps on the ride. They're a little bit darker red. You might say blue, but it's not really a drastic color change from a little bit darker red to a little bit brighter red when the carbon dioxide jumps off and the oxygen jumps on. Interesting thing about carbon monoxide poisoning, the reason that exhaust from a vehicle is so dangerous, carbon monoxide is 1,200 times more strongly attracted to this red blood cell and the molecule called hemoglobin. So a carbon monoxide molecule is sort of like a bully at whoop-up days. First of all, it's going to skip the line. It's going to run in front of all the oxygen that's waiting to get onto a red blood cell. And then once it pushes the oxygen out of the way to jump onto the red blood cell, so the oxygen can't, it's also going to be like a bully at the fair that stays on the ride over and over and over again and doesn't ever get out and leave the seat to somebody else. So eventually what can happen is all of the red blood cells in your body can be tied to a molecule of carbon monoxide, and that means that all of the cells in your body aren't getting the oxygen that they need, and you can die from carbon monoxide exposure. That's why you should never start a car with the garage door closed. The blood vessels that surround the alveoli are filled with oxygen depleted, that means it's run out, oxygen depleted blood. Because of diffusion, oxygen moves from an area of high to low concentration, moving oxygen into the bloodstream by a process called diffusion. Alveoli are specialized cells. They're one cell layer thick to allow for the diffusion of materials in and out of the lungs and blood vessels. Each lung has over 2 million alveoli, which provide, when you add it all up, a surface area equal to about 800 square feet. That's almost the size of one side of the volleyball court. Pretty crazy, considering all of your surface area of your skin only adds up to about 10 square feet. That's what it looks like, highly magnified, pretty cool. The alveoli are small sacs surrounded by blood vessels. walls of the sac and the walls of the surrounding blood vessels are very thin, allowing for diffusion of gases in either direction. When the blood vessels pass by the alveoli, oxygen diffuses into the blood and carbon dioxide diffuses out. Leaves us just one last part to look at. It's called the diaphragm, and that's the muscle across the bottom that pulls the bottom of the rib cage open and draws air into the lungs. It looks like this. We'll leave this flash animation running in the background. It's the muscle that draws air into the lungs, and it works like this. As the diaphragm relaxes, it allows the rib cage to fall closed and move air out. When it contracts, it draws the bottom of the rib cage down and pulls air into the lungs. I'll let you keep watching that. Singers, of course, learn to use their diaphragm to control their breathing and their singing voices. It takes years of practice. And now, some cases, the more interesting part, the things that can go wrong. I'm sure there are some asthmatics in the building. You know, asthma typically is a very similar reaction to an allergic reaction, where this is what happens. It's the inflammation of the bronchioles that prevents air traveling through the system. Treatment needs to happen immediately when asthma attacks. So that's a normal, healthy airway. When that airway gets inflamed for different reasons, asthma can have different triggers, but that muscle gets angry. It's sort of like when you sprain your ankle gets swollen. What swelling is an increased blood flow to the site of the damage, because your circulatory system realizes, whoa, we got to get all hands on deck, try to fix this damage. So for whatever reason, this muscle surrounding your airway gets inflamed and swells up. It also squeezes just a little bit of extra mucus into the lining of that airway, which obviously makes it a lot harder for the air to get through. Treatment for that, a couple of things. Just like an allergic reaction, it can be a shot of epinephrine, adrenaline. They're the same thing, epinephrine and adrenaline. That's what your body releases in the case of a fight or flight response, and it prepares your body to burn a lot of energy. One of those responses is to open the airways. The airways open to prepare for more oxygen to fuel your muscles for more work. So a shot of adrenaline can help counter this inflammation right here. It can be either taken IM, which means intramuscular, which means needle, or it can be inhaled. The only problem with an inhaled treatment is that it needs to be done quickly, because this airway has the potential to swell to the point where even that inhaled medicine can't get to where it needs to go. So the treatment needs to happen quickly. Lung disease is a broad term to describe lots of different things. Most of those problems can be caused by smoking. We're going to look at bronchitis, emphysema, and quick look at lung cancer. Bronchitis, we've seen this word itis before. When we looked at appendicitis, that means an inflammation of your appendix. Bronchitis is an inflammation of your bronchi. Now, it looks the same as our asthmatic response. This one is specifically triggered by all of the poisonous, terrible stuff that you inhale with cigarette smoke. So eventually that can trigger this bronchitis response. Emphysema is when your lungs get coated with the tar inside a cigarette. These tiny microscopic balloons called alveoli, they'll start to get brittle when they get coated with this tar, and they'll actually pop. So instead of having this much and this much and this much and this much surface area, you just have this much. You lose a lot of surface area. You lose the effectiveness of parts of your lung. So you lose lung capacity. This is what it looks like on the outside. Well, you just saw another example of a healthy lung. It's kind of pink. when it's affected by emphysema, it'll actually turn black, just like the tar. Lung cancer just means an abnormal growth, again, triggered by some of the chemicals in a cigarette. And it can grow a tumor that little by little starts to constrict these airways. Just a couple of quick videos again to underscore the dangers of 3 chemicals that are found in cigarettes: arsenic, benzene, and formaldehyde. I'm going to stop the video there and add a second video of just these 3 videos.